Hey guys, welcome back to QST. We're going to be doing chapter 4.4 course revision for chemistry periodic. Let's get started. And uh, we're going to be balancing the equation. N2H4 plus O2 gives H2O plus N2. Okay, so N, we have two N's, 4 hydrogen, 2 oxygen on this side, hydrogen 2, oxygen 1, nitrogen 2. Okay, so we're gonna be balancing. So we have nitrogen is balanced. We need to balance oxygen and hydrogen. Okay, we have both of them over here. Just give the coefficient of 2. So here the hydrogen becomes 4 and here the oxygen becomes 2. So they're all equal. Okay, all of them are equal. So yeah, that's the balanced equation. Just a coefficient of 2 next to H2O. Okay, how many molecules of nitrogen does one molecule of N2H4 give? Okay, so we have one molecule of H24. Okay, we have one molecule of N2H4 will give you all of these are 1 except for H2O. So one molecule of N2H4 will give you one molecule of nitrogen. That's it. How many molecules of water does one molecule of N2H4 give? Okay, one like the one before. N2H4 is one molecule and water is 2 molecules. So one molecule of N2H4 gives 2 molecules of water. How many moles of nitrogen does one mole of N2H4 give? Same thing. So one mole of N2H4 gives 1 mole of nitrogen. How many moles of water does 1 mole of N2H4 give? 1 mole of N2H4 gives 1 mole of water. Okay, in the above balanced equation, how many moles of N2H4 are required to form 16 moles of H2O? No, H2O. Okay, so we're gonna write the MCR ratio N2H4 to H2O. Okay, so how many moles of N2H4 are required to form 16 moles of H2O? The ratio is 1 to 2. We need 16 moles of H2O. So how many moles of N2H4? Cross multiply 16 divided by 2 is equal to 8. 8 moles of N2H4 required. Okay, how many grams are there in 1 mole of N2H4? So how many grams are there? Okay, for the grams, we know it's one molecule. I mean 1 mole, and I'm gonna write the molar mass of all of them here. So nitrogen molar mass is 14. Yeah, nitrogen molar mass is 14. Hydrogen is 1. Okay, so we have 2 nitrogen and 4 hydrogen. So that's going to be 28 plus 4. Okay, that will give you 32 molar mass. And now we know it's 1 mole. So we know N is equal to M over M, and M is equal to Mn. So molar mass 32 multiplied by 1. That's it. So N2H4, there is 32 grams of N2H4. Okay. Now, how many grams are there in 3 moles of H2? Okay, 3 moles of H2. So H2, like I said, H is 1, so H2 is 2. So that's the molar mass, and 3 moles. Multiply the molar mass by the mole, 3 times 2. So 3 times 2 will give you 6. That's it. Write the ratios of reactants and products by mass. Verify that these ratios conserve mass. Okay, ratios of reactants and products by mass. Okay, so we know we found 32 to be N2H4 and O2. Okay, I'm gonna start from scratch here. Okay, N2H4 plus O2 gives you 2H2O plus N2. Okay, so N2H4, okay, we found it to be 32 for 1 mole. Okay, and there's only 1 mole. O2 is, so I'm gonna write over here the molar mass of O2 is 16. So O2 is 32. Now H2, H is 1, so the H is diatomic, so that's 2, and oxygen is 16, so 16 plus 2, 18, but then there's 2 moles, so that's going to be 36. Okay, plus N is 14, N2, so it's going to be 28. When you add them, you'll get 64 on both sides. Okay, 64. Okay, yeah, this is the ratio of mass, and It's equal. It conserves. It conserves mass. Okay. Next question. Ethane has the formula C2H6. Its combustion products are carbon dioxide and water. Okay. Okay, so write the balanced equation for the combustion of ethane. Okay, so we have C over here, H over here, and O being 2. Okay, now write them in order. C1, H2, O. 1 plus 2. Okay, now O2. Okay, actually, no, we're not going to balance O. We'll leave that for the end. Yeah, we need to balance hydrogen and carbon first. So we're going to multiply this part by 2, okay, which will make carbon 2, and hydrogen this part as well 2. That's going to be, actually no, we're going to multiply that by 3. So that's going to make hydrogen 6 and carbon 2, okay? But then what does that make? That makes oxygen on this side 3 plus 2 times 4, so 2 times 2 4, so that's 7 on this side, while there's only 2 on this side, on the other side. So to make it even, we know O2, we can multiply that by 7 divided by 2, which is 3.5. Okay, 7 divided by 2. But then if they're going to want it in the integers, as in sorry, are whole numbers, smallest whole numbers, then we're gonna have to multiply everything by 2. Okay, because at this point 7 over 2 times O2 will give you 7. Okay, it's 7. But then if they're going to want it in whole numbers, we can do 2. This is 2 over here, yeah, just multiply everything by 2 times 2 times 2 times 2. So I'm gonna write this again. Actually no, I'll just write it down. So 2C2H6 plus 7O2 gives you 3H2O plus 2CO2. Okay, that's the balanced equation. We have all of them balanced. Okay, now write the ratios of reactants and products in moles. In moles. Okay, I'm gonna write it again. Sorry, 2C2H6 plus 7O2 gives you 6H2O, yeah, 6H2 plus 2 times 2, yeah, 4CO2. Wait, let me just make sure it's okay. 14. Yes, that is okay. Okay, write the ratios of reactants and products in moles. Ratios of reactants and products in moles. Okay, we have all of the moles here. It's 2, 7, 6, 4. That's it. Just write that. That's it. The ratios of reactants and products in moles. Okay, now the ratios of reactants and products in grams. We know that M is equal to molar mass times moles. So we just need to find the molar mass. So I'm going to be writing everything down. Carbon. Oh my god. No. Okay. 2C2H6 plus 7O2. You can skip this part. Okay, I'm just rewriting this because I keep messing it up every time. 6H2O plus 4CO2. Okay, yeah, like I said, 2, 7, 6, 4. Okay, ratios of reactants and products in grams. So C, I'm gonna write all of the values here. C is 12. Hydrogen, is 1. Oxygen is 16. Yeah, that's all we need. Okay, so 2 2 times C2H6. C2H6 is 2 carbon and 6 hydrogen. So that's going to be 6 plus 24, which will give you 30, but it's moles, so it's going to be 60. 60 grams. And O2 is 16, is the molar mass multiplied by the moles. Okay, let me just see. Oh, wait, no. Yeah, 16 is diatomic, so it's going to be 32. Multiplied by the molar mass, so it's, no, multiplied by the mole, so 7 times 32 will give you 224. 224, yes. 224. Okay. Actually, no need of the plus, but like, just for conservation, to prove it. Okay, 6H2O. H2O is 18 times 6. So that will give you 108. And for CO2, CO2 is carbon and 2 oxygen. So 32 plus 12, which will be 44. Yes, 44. Yeah, no need plus. So if you want to verify, just do 60 plus 20, 224, which is 284 minus 108 plus, no, minus 44. You get, wait, what did I do here? 10 times 6 is 108 CO2. Oh, right. Carbon. Oxygen is diatomic, so 32. But wait, what? Yeah, I didn't multiply the 44 by 4. Sorry. 44 by 4 will be 176. Yes, 176. Now, if you add them together on both sides, it's going to be 284 on both sides. That's it. 284, yes. So it's equal. No, it's. Write the ratios of reactants and products by volume at STP. Okay. We have the volumes. We have 2, 6, 7. No, 2, 7, 2, 7, 6, 4. Yeah, 2, 7, 6, 4. Okay, those were the ratios. So STP is 22.4. Now just multiply 2 by 22.4, 7 by 22.4, 6 times 22.4, and 4 by 22.4. If you do it in the calculator, I'm just going to do it really fast. This is going to be 44.8. This is going to be 156.8. And then we have 134.4. And finally we have 99.6. Sorry for the very bad handwriting, but yeah, we have 89.6. Okay, there. That is the ratios and volumes. Okay, 1 mole of ethane produces how many moles of water? Okay, ethane. Okay, I'm gonna read it again. Okay. 1 mole of ethane produces how many moles of water? Ethane. What is ethane? Ethane is this one, this boy. Okay. How many mole? 1 mole of ethane produces how many moles of water? Okay, so it's water. Okay, so the ratio is 2 to 6. Yeah, you remember 2 to 6. That was the ratio of C2H6 to H2. I'm gonna write here C2H6 and H2O. Okay, 1 mole of ethane. Okay, 1 mole produces how much? Just cross multiply. You get X is equal to 3. It's not that hard. Okay. 4 moles of ethane combined with what volume of oxygen at STP? Okay, so we know 4 moles of ethane. Okay, 4 moles. It's just multiplication. Oh wait, no. Yeah. Okay, gotcha. So we have the ratio 2 to 7, right? 4 moles of ethane combined with what volume of oxygen at STP? Okay, so 4 moles of ethane combined with what volume of oxygen at STP? 20.4. Okay, 4 times 22.4 over here is going to be, okay, we have to do 4 over times 22.4 because that's ethane's volume. So 4 times 22.4, we get 89.6 over here. Okay, so how much will this be? This is the volume. Okay, this is the volume of ethane and STP. So how much will the volume of this one be? So just cross multiply. We have 89.6 times 7 divided by 2. We get 313.6. We have to multiply by 5. 1 second. Okay, yeah, I just had to make sure. Yes, that's correct. Multiply this by 7, this by 2, we get 313.6. That is the moles of ethane that will combine with the volume of oxygen, that is STP. Okay. Now, actually, there is a much simpler way, which is 2 to 7, 4 to 4, uh, 4 to x. Just do that. You'll get 14 over here, and then just multiply that by 22.4. But yeah, same. Okay. 4 moles of ethane combined with what volume of air at STP, knowing that air is 20% oxygen. So air is 20% oxygen. Let's make that 100%. So just multiply 313, the one that we found right now. Multiply that by 5. Let's see, what do you get? 313.6 times 5. You get 1568. Yes. 1568 for the volume. Okay, that's it. It's like the one we get in the quiz all the time. The same question. The same type of question. Okay, next one. Okay, so carbon burns in air according to the following balance equation. C plus O2 gives you CO2. Okay, 1 mass of carbon dioxide can be produced by 36 grams of carbon. Okay, so the ratio is 1 to 1. Okay, now we can either do all of them in moles, or we can just make them grams. It's easier right now to make them grams. Okay, so 1 mole of carbon will have 12 grams. Okay, so 1 mole is 12 grams. Okay, and 1 mole of CO2, as we say, C is 12 and O is 16. So 32 plus 12, 44. Okay, 44. Now, oh, that looks like 9. Right. Yeah, 44. Okay, now 12 and 44. If we produce 36 grams, how many will we produce here? Just cross multiply. 36 times 44 divided by 12 will give you 132. That's it. Okay, iron reacts with chlorine to produce ferric chloride. The equation of the reaction is represented below. Fe plus Cl2 plus is equal to FeCl3. Okay, we need to balance. So Fe is equal to 1, Cl is equal to 2. Okay, Fe here is 1, Cl is 3. Okay, so we need to balance the chlorine. Okay, chlorine, we can make this 2, we can make this, no, we can make this here 3 and here 2. So that's going to make this one 6 as well as this one 6. Okay, but then Fe over here becomes 2, so just make this one also 2. So 2Fe plus 3Cl2 gives you 2FeCl3. So they're all balanced now. Okay. Write the reacting ratios in moles. Like we said, 2, 3, 2. Yeah. How many moles of iron are required to form a mole of FeCl? 4 moles of FeCl3. Okay. So how many moles of iron? Just gonna draw 2, 3, 2. Okay. How many moles of iron? Okay, iron is Fe, produce FeCl3. So the ratio is 2 to 2. Okay, to form 4 moles of Cl3, it's going to be 4 because it's the same. It's 2 to 2, so it would also be 4 over here. So that's it for that. How many moles of iron? No, 1 mass of FeCl3 is produced when 35.5 gram of chlorine is consumed. Okay, 1 mass of FeCl3. Okay, FeCl3 when 35.5 gram of chlorine is consumed. Like we said before, we can make it all into grams. Okay, so FeCl3 and chlorine. It's FeCl3 and chlorine. Chlorine is 3 to 2. Chlorine is Cl2 over here, and FeCl3. Okay, so 3 to 2. 3 moles of chlorine will have Cl is Cl chlorine. How many moles? How many molar mass is chlorine? 1 second. Alright guys, so chlorine is apparently 35.5 molar mass, but then since it's a big number, we're just gonna do a different method over here. Like I said, we can either make them all moles or make them all grams. But then let's just do moles here because the number is big. So 3 to 2. Hmm? We have 35.5 grams of chlorine. Okay, 35.5 grams of chlorine. Okay, 35.5. Let's make that into moles. Okay, so we have N is equal to M over M. Molar mass of chlorine is 35.5 for 1. So 2 is going to be 71. So just do 35.5 over 71 to find the moles. So 35.5 divided by 71 will give you 0.5 moles, okay? So I'm going to write this again over here. So 3 to 2, 0.5. So how many moles will be produced over here? Okay, cross multiply 0.5 times 2 divided by 3 will get 0.33. Yeah, 3333. Okay, now to find the mass of FeCl3, we have to multiply the molar mass. I mean, no, the moles by the molar mass, yes. So over there we have FeCl3, Fe. Okay, now I need to check Fe. 1 second. Alright guys, so apparently each Fe atom is 56 molar mass, okay? So I'm gonna write it here, Fe is equal to 56, okay. Now, 0.33 is the mole. Now multiply that by FeCl3. Cl once again is 35.5. There are 3 of them, so that's going to be 100. And when doing the calculator, it's going to be 106.5. That's 3 Cls plus 56, which should give you 162.5. Okay, so the total molar mass is 162.5. You multiply 0.333333, yeah, okay, so 0.33333 multiplied by 162.5 will give you 54.166. Yeah, okay, let's do 0.3 times 162.5. Okay, now let's go for next one. Wait, there's one more. What mass of Fe is consumed when in the process when 35.5 grams of chlorine reacts? Okay, we know the balanced equation is 232. Yeah, okay, 232. Yes. Okay, so what mass of Fe is consumed in the process when 35.5 grams of chlorine? Okay, Fe 2, chlorine 3. Okay, what mass of Fe consumed in the process? 35.5 gram of chlorine react. Okay, chlorine 35.5. Okay, 35.5 divided by 71 as we did in the first place. So over here we'll have a mole of 0.5, okay, which is 35.5 over 71, which will give you, when you cross multiply, and 0.5 divided by 3 will give you 0.333333. Yeah, 0.3333 like we did last time, okay? But now to find the mass of Fe consumed, just multiply by Fe. So Fe is 56 as we discussed before. So that's 0.333 times 56 to find the mass. M is equal to molar mass times mole. So 0.333 times 56 will give you 18.666 or 18.7. Yeah, 18.66. Yeah, that's it, 18.66. Okay, mind if I pause sometimes. I'm just making sure that I'm teaching the right stuff. Okay, yeah, I was correct. Okay, what does the term standard temperature and pressure, STP, mean? So standard temperature and pressure, okay, that is when the temperature is 0 and the pressure is 1 atmosphere. Okay, remember oh my god, okay, STP is equal to 0 Celsius and 1 ATM. Okay, okay. Consider the following equation. Yeah, okay. Carbon bonds. Okay, carbon bonds and air according to the following balance equation below. C plus O2, CO2. Okay. What volume of O2 at RTP? RTP is 24, remember that. Will produce 4 moles of CO2. Okay, so we have it's already balanced, so we have easy work. CO2. It's all 1 to 1 ratio, okay? One volume of O2 at RTP will produce 4 moles of CO2. Okay, so 4 and how many we want how many okay, this is O2 by the way, and this is CO2. We want 4 moles of CO2 and how many volume will produce that, okay? It's a 1 to 1 ratio, so 4 moles, okay? 4 moles, but then we want it in volume, and it's an RTP. RTP is 24, so just do 4 times 24, okay? Which will consequently give you 96. Yes, 96. That's it. Consider the following equation. 3H2 plus N2 is 2NH3 is balanced. Yes, it is balanced. Yes, it's balanced. Okay. Determine the volume of N2 measured at RTP conditions that react completely with 12 gram of H2. Okay, so right. Okay. N2 and H2. So that's a ratio of 1 to 2. No, my bad, sorry. 1 to 3. Yes. Determine the volume of N2 that reacts completely with 12 gram of H2O. So this is N, by the way, this is N2, and this is 3, this is H2. Okay, now 12 grams of H2, 12 grams of H2, let's make that moles, okay? Because either way, at the end we need to find the volume, which is moles times the RTP, so we need to find the moles. So 12, we're going to make that into moles. We know that H is 1, so H2 is 2, so mass over molar mass, 12 divided by 2 will give you 6, okay? So here will be 6, 6 as the, yeah, this will be 6 moles, sorry, yeah, this will be 6 moles. If this is 6 moles, then we can cross multiply and find this one, which will be 18 moles. Wait, what? Sorry, 1 second. Oh wait, yeah, sorry, I multiplied it by 3, sorry, didn't divide. Okay, so 6 divided by 3 will give you 2. Yes, that's it, 2 to 6. So N2 is 2 moles, but then we need to find that in volume. Volume, so it's RTP, by the way. Yeah, RTP is 24. 2 times 24 will give you 48. Okay, 48. Okay, that's it. Okay, determine the volume of NH3 produced under the same conditions. NH3. Okay, they want NH3 this time. The ratio. Okay. Okay, so it's H2, so which is 3 to volume of NH3. NH3 is 2 ratio over here. Like we said before, 12 grams of H2 is 6 moles. So this over here is going to be 6 times 2, 12 divided by 3, 4. Yeah, 4. Now 4, multiply that by 24 to make it RTP. So that's going to be 96. Yes, that's it, 96. If 33.6 decimeter cube of H2 are completely measured at STP, determine the number of moles of N2 needed. Okay. So H2 and N2 is one we're going to be using here. So 3 to 1. 33.6 decimeter cube of H2. Okay. 33.6 measured at STP. STP is what? 22.4. So basically just do 33.6 divided by 22.4 to find the number of moles, which will give you 1.5. Okay. So 33.6 volume. To make it into moles, you have to divide it, measure STP, so divided by 22.4 will give you 1.5. Now that this is, we can just cross multiply, will give you 0.5. Okay, that's it, still 0.5 moles. Yeah. Okay, so a reaction, no, a piece of potassium metal solid that is lowered into a bottle of chlorine gas. Okay, a reaction takes place. A salt KCl is formed. So K plus Cl2 will give you, no, 2K plus Cl2 will give you 2KCl. Am I right? Wait 1 second. Yeah, that's the balanced equation, because that is the balanced equation, okay? Because K is group 1, Cl is 2, like that. So yeah, that's the balanced equation, okay? 2K plus Cl2, 2KCl. Now, write the balanced, okay? How many moles of KCl could be formed from 3.55 grams of Cl2? Okay, so how many moles of KCl? Cl2. Okay, Cl2 is 1 to 2. So 1 to 2, this is Cl, okay? And this is K. Oh, no. Yeah, it's KCl, okay. Cl2, how many moles from 35.5 grams? Okay, easy. 35.5, we make that into, 3.55, we make that into moles. N is equal to M over M. Cl, chlorine, is 35.5, so Cl2 is going to be 70. So 3.55 over 70, 71, my bad, sorry, 71. 3.55 divided by 71 gives you 0.05, yes, 0.05. Okay, now just cross multiply. How much do you get? You get 1, sorry, 0.1, yes, 0.1. That's it. Propane burns in air according to the following balanced equation. C3H8 plus F5O2 gives you 3CO2 plus 4H2O. 1 mass of C3H8 is required to react with 80 grams of oxygen. Okay, so oxygen, C3H8. Okay, so the ratio is 5, which is oxygen, to 1. 80 grams of oxygen. Like I said before, oxygen, you could just make it into moles. Since they want mass over here, okay, they give 80 grams over here, okay? And they want oxygen, the mass of C3H8, okay? We have 80 grams of oxygen, 5 moles. Just multiply that by the molar mass, we can get the grams. So O2, O is 16, O2 is 32. 32 times 5, which will be 160, okay? So 160 is equal to C3H8 is C3H8. C is 12, H is 8, 12, 12, 12, 36 plus 8, 46. No, 36, 8, 44, yes. 44, okay. So 160 to 44, you find the mass of C3H, the new mass. Okay, just cross multiply 80 times 44 divided by 160 will give you 22. Yes, that's it. Alright guys, for this question, consider the reaction between the hydrogen and oxygen to produce water, which releases 284 kilojoule per mole of hydrogen. Okay, how much? So first off, I'm gonna write the equation. Okay, H2 plus O2 gives H2O, but O is 1 over here, O is 2 over here. You're gonna do this 1 over 2 O2. Okay, you're gonna split that into half. Okay, now we could make it whole numbers, but then the thing is, they say 284 kilojoule per mole. It's gonna get you confused if you make it 2 over here. Okay, just don't do that, it's gonna kill you. Okay, so how much heat is released when 0.2 moles of hydrogen are used? Okay, so 284 kilojoule per mole, so 1 mole gives you 284. 0.2 gives you how much? Just cross multiply, no big deal. 0.2 times 284 gives you 56.8. That's it, 56.8. Okay, how much heat is released when 8 grams of oxygen are used? Okay, so yeah, so heat is released in 8 grams of oxygen. Okay, so hydrogen, which is 1, and oxygen, which is 0.5, okay? Half. That's the ratio. And 8 grams of oxygen is used. 8 grams divided by O, okay? Because it's just O, it's not 2. Okay, just O, just O. So 16 is O. So 8 over 16 will give you 0.5 as the moles, okay? Wow, okay. 0.5 as the moles. Now just cross multiply. 0, 1, x. Okay. So that's going to be 0.5 as well. Oh no, wait, what? 0.5 times 1 is 0.5. So 0.5 divided by 0.5 is going to be 1. I'm crashing out again, 1 second. Alright guys, forget what I did just did right now, okay? What we can do is H2 plus 1 over 2 O 2 gives you H2O. Okay, we know that like it's 1 to 0.5, okay? That's the ratio of hydrogen to oxygen. Now 0.5 as in O is 16, okay? 0.5, which is half of O2, okay, is 16. O2 is 32, 0.5, 16, okay? So we can replace this over here by 16, because that is 16 grams, right? 16 grams. 16 grams gives you, and we can over here, instead of 1, we can say 284. No need to say 1, because 284 is 1 mole. Like every mole gives you 284. So if this is 16, then 8 is how much? Just cross multiply. 284 times 8 divided by 16, okay? Forget what I said you all about the other one, okay? I messed up a bit, yeah? So when you do that, you get 142, okay? That's it. Okay, balance the equations for the decomposition of nitrogen fluoride, NF3, and nitrogen trichloride. Okay, so I want to zoom in. Okay, we have N1, F3, N2, F2. All of them need to balance, okay? So if we multiply this over 2 over here, okay, that will make N2 and F6, okay? And that way we have N2 balanced, okay? N is balanced, and F, we just need to multiply this by 3 to make this also 6. So that's that, okay? 2NF3 is equal to N2 plus 3F2, okay? And then N1Cl3 N2Cl2, okay? So over here we need to balance again, so 2N will make it 2 over here, both of them side 2, and that will make Cl6. And then we just do this over here, we put 3 next to the Cl2 over this on this side, that'll be 6 over here. So they're all balanced again, okay? All of them are balanced. 2NCl3 is equal to N2 plus 3Cl2, okay? Okay, rewrite the equations to include the information from the decomposition of NF3 is endothermic. Endothermic absorb. So the endothermic is going to be with the reactants, not the products. Exothermic is with the products, okay? So I'm just going to rewrite everything over here, okay, on this side. So we have 2NF3 gives you N2 plus 3F2. Okay, they said absorbing 232 kilojoule per mole of N2. We have how many moles here? Okay, we only have 1 mole of N2. Okay, just one. So yeah, so it's just gonna be 232. So 2NF3 plus 232 gives you N2 plus 3F. Okay, next one. 2NCl3 gives you N2 plus 3Cl2. Okay. 457. Yeah, release NCl is exothermic. Exothermic means releasing 457 kilojoules. So it's going to be on the product side, okay? So it's going to be 2 NCl3. Wait, what? Yeah, okay. 2 NCl3 equals to N2 plus. We only have 1 mole of nitrogen, so plus 457. Yeah, that's it. And don't forget the units, kilojoule per mole. Wow, okay. Given the equation 4NH3 plus 7O2 gives you 6H2O plus 4NO2, what is the mass reacting ratios for the above equation? Mass we know is equal to mass is equal to mn. Okay, we all already know the moles 4764. Okay, so mass reacting ratios. Okay, 4 for the first one, NH3, n is 14. So we have 1 n and 3 h, so 14 plus 3 is 17. So 17 times 4 for the first one will give you 68. Yes, so that's going to be equal to 68. So the first one, 68. No, that's too small. Yeah, okay, it'll be 68. Okay, next one, 702. O is 16, so O2 is 32. 32 times 7 is going to be 224. Okay, 224. 6H2O. H is 1, so 2H and O 18. 18 times 6 is going to be 108. 108. And 4NO2. N is 14, yes. So N is 14, O is 16, 32 plus 14, 32 plus 14 times 4, 32 plus 14, 32, yeah, 32 plus 14 times 4 will give you 184. 184, that is the reacting ratios of mass. Okay, yeah, okay. In the balanced equation below, let STP, write the reacting ratio by volume of reactants and products. Okay, we know how to calculate the volume. Okay, we said STP. STP is what? 22.4. And we know how to calculate the volume, moles times the volume, which is, STP or RTP. Okay, so we have all the moles here, 2, 7, 4, 6. Okay, so 2 times 22.4 will give you 44.8. Okay, so the first one is going to be 44.8. Okay, second one, 7 times 22.4. Okay, 7 times 22.4 will give you 156.8. Yes, 156.8. For CO2, 4 times 22.4 will give you 89.6. And H2O, 6 times 22.4 will give you 134.4. 134.4. Those are the reacting ratios in volume. Okay, and if you want to, okay, these three are important ones. Those are the big ones. Okay, limiting and excessive ones. People usually have trouble with this. So iron Fe burns to form a black solid Fe3O4. Can a 4.6 gram piece of iron F 5.6 gram burn completely to burn Fe3O4 in a vessel containing 1.12 decimeter cube of O2 at STP conditions? Okay, so first of all, what do they give you? Okay, they give you the mass of the iron, which is 5.6. Okay, can a 4.6 gram piece of iron, 5.6 gram. Okay, the original is 4.6, but then 5.6 is the one that we have given. Okay, and in a vessel containing how much volume? 1.12 decimeter cube of O2. Okay, first step when you find limiting and accessing, make them into moles. Okay, so first off, I'm going to write the equation. Okay, Fe plus O2 is going to be 2O2, 3Fe, giving you Fe3O4. So Fe3O4. Oh, 4. Yes, okay. So we know 5.6 gram, okay, of iron. So 5.6 divided, to find moles is n is equal to m over m, as we always know. N is equal to m over m. Mass 5.6 over molar mass. What is molar mass of Fe? Fe is 56, I've told you before. So 56, okay? Let's get that straight. Now, O2, 1.12 is the volume. We know from volume to moles is divided by the STP or RTP depending on what they give. So 1.12 divided by, they gave here STP, so 22.4. Okay, so what do you get? Over here, Fe is 0.1, and over here 1.12 divided by 22.4 is to give you 0.05. Okay, 0.05. Wait 1 second. 5.6 or 5.6 divided by 56. Yeah, okay, 0.1. Okay. Next step in excess and limiting is to divide the number by the coefficient. Okay, so 0.1 over 3. Yeah, and then 0.05 over 2. So 0.1 divided by 3 will give you 0.033333. Okay, a never ending amount of 3. And 0.05 divided by 2 will give you 0.025. Now, what did they ask you? Can a 4.6 gram piece of iron 5.6 gram burn completely to form Fe3O4? So what we have, 0.3 and 0.025. Which one is bigger? 0.3 is bigger. So which one is excess? 0.3. The iron is excess, and the 0.025 looks like a 1. Okay, no, I can't fix it. Okay, my bad. 0.025, that is the oxygen. Okay, oxygen in this case is the limiting. Okay, 0.3 is the excess, so iron is excess, and the other one, which is oxygen, is limiting. Yes, okay. So can it burn completely? Not all of it will burn, like only 0.025, not the full thing. Okay, 0.3, not the whole thing will burn. Okay, only some of it, not the full thing. Okay, next question. 5 moles of graphite were burned into a vessel containing 10 moles of oxygen gas. What is the maximum number of moles of carbon dioxide that could be produced? Okay, I'm gonna write this down. Carbon, oxygen, CO2. Okay, 1 second. And oh yeah, by the way guys, I made a mistake over here, which was which question? Yeah, ratio by volume. I said that this one, I said the volume of the this one, but then this is liquid. Okay, volume for liquid and solid is always negligible. Okay, only gas, they only take gas. Okay, I checked the answer sheet, I just realized. Okay, my bad, sorry. So this is out. Okay, you only put these 3. Okay, this one is negligible. Okay, back to the question. Okay, so what do you have? Okay, so I'm gonna write the equation. C plus O2 gives you CO2. Okay, 5 moles of graphite were burned in a vessel containing 10 moles of oxygen gas. What is the maximum number of moles of carbon dioxide that could be produced? Okay, again, what did they give you? 5 moles of graphite and 10 moles of oxygen gas. So 5 moles, 10 moles. They already gave you the moles, thankfully. So now divide by the coefficient, both of them coefficient 1, so it's not really going to change. 5 and 10, that's it. Okay, like if you want divide by 1, it's just going to be 5 and 10. There's no point. Okay, so which one is excess and limiting here? Of course, oxygen is the excess, carbon is the limiting, right? So we can say what did they ask? Maximum number of moles of carbon dioxide that could be produced. Okay, so we know the ratio of carbon to carbon dioxide is 1 to 1. So we have 5 moles of carbon, okay? How many moles is the maximum number of moles that can be produced? 5. That's it. It's so simple. It's that's easy, okay? That's it. Given NO2 plus H2O plus HNO3 plus NO, how many moles of nitrogen monoxide are formed from 13.44 decimeter cube of nitrogen dioxide STP and 4.5 gram of water? I'm going to have to write the molar mass. Okay. Alright, let me just make that over here real quick. N is equal to 14. Actually, no, not everything. I'm just going to write the one for water. We already know water H2. Okay, so we know the equation. I'm gonna zoom in a bit. Yeah, actually, no, you need to see the equation. Okay, 13.44 decimeter cube of nitrogen dioxide and 4.5 gram of water. Okay. Okay, NO2 is 13.44. Like I always say, what do they give? They give 13.44 volume of nitrogen dioxide. Okay, and how much gram of water? They give 4.5 gram of water. Okay, now make that into moles. 13.44. It said STP, so divide that by 22.4. So 13.44 over 22.4. What do you get? You get 0.6 as some moles. Okay. 4.4. N is equal to M over M. Okay, we have the mass is 4.5. Divide that by the molar mass, H2O. I said H is 1, O is 16, so that's going to be 18 because it's H2, of course. So 4.5 divided by 18 will give you 0.25. Now we divide by the coefficient, but the coefficients are all 1, so it's 0.6 and 0.25. Which one is bigger? 0.6 is bigger. So what is bigger? The nitrogen dioxide is bigger. So nitrogen dioxide is the excess. It's a lot. It's way more than there is of water, okay? Water is the limiting reagent. Nitrogen dioxide is the excess reagent. Okay, how many moles of nitrogen monoxide are formed from 13.44 decimeter cube of nitrogen dioxide, 4.5 gram of water? Wait, what are they asking? Okay. Ratio from nitrogen monoxide, dioxide and water is 1 to 1. You get 0.6. Wait 1 second. Oh wow, guys, I just realized you had to balance the equation. I just checked the answer sheet. I'm so sorry, I forgot. Okay, we're gonna start over again. Okay, forget this ever happened. NO2, H2O, NHNO3 plus NO. This is exhausting. N1, O is 2, H is 2, and wait, actually, I'm just gonna write O plus 1. Okay, H over this side 1, N 1, O 3 plus 1 because we have over here. Okay, N plus 1. Yeah, okay, we need to balance. Okay, so when we balance, we're going to get, okay, so hydrogen. Okay, first off, I think it's better to balance this one. 2 NO will make this one 2, and oxygen 2 plus 2 times 2 4. Okay, that makes it 5. Okay, in total. Okay, if that is 2, then this is nitrogen is balanced, but then oxygen, we need to double that, so this becomes 2. That way oxygen is also 5. Okay, but then that way nitrogen, okay, yeah, oxygen always last. I forgot, oxygen always last. Yeah, I have to write everything again. So N1 O2 plus 1 H2. Okay, I'm gonna make this fast. Okay, H1 N1 O 3 plus 1 plus 1. Okay, H multiply by 2. Okay, 2, N becomes 2 plus 1, O becomes 6 plus 1. H is balanced, N is 2 plus 1 and 3. So over here 3, we're gonna do that. So that way we have, no wait, what? No, yeah, okay. I'm right, I'm right. N is 3, and that way we have oxygen being 6 plus 1, 7. Yeah. Oh, we balanced everything. Wow, okay, that was quick. So nitrogen 2 plus 1, 3, oxygen 6 plus 1, 6 plus 1, H2, H2. Wow, okay, that was quick. Okay. 3NO 2 plus H2O gives you HNO3 plus NO. Yes, everything is balanced. Or is it? Let me just make sure. 1 second. Yes, it is balanced. So 3NO2. Wait. Okay, 3NO2 plus H2O gives you 2HNO3 plus NO. Okay. So how many moles of nitrogen monoxide are formed from 13.44, 13.44 decimeter cube of nitrogen dioxide at STP and 4.5 grams of water? Like I always say, what do they give you? Okay, 13.44 decimeter cube of nitrogen monoxide. 13.44. H2O 4.5 grams. Okay, so 13.44 volume 2. uh, volume to moles is always divided by the STP or RTP based on what they give you. They give you STP. So 13.44 over 22.4 gives you 0.6. And 4.5 over the mass over molar mass, so over the molar mass of H2O is 18 because H2 is 1, 2, O is 16, 2 plus 16, 18. Okay, 4.5 divided by 18 is 0.25. Okay, now as I say, you want to divide it by the coefficient. Okay, so 0.6 divided by the coefficient is 3. So there's no, this is 1, so 0 point, I'm gonna rewrite everything here. So the 0.2, 0.2 and 0.25, that is nitrogen monoxide and H2O. Yes, H2O. Okay, 0.2 and 0.25. Which one is the excess? Watch is excess. Which one is limiting? Nitrogen monoxide. Okay, now now they want how many moles of nitrogen monoxide are formed. Okay, so the ratio is 3 to 1. We have uh 0, wait, how many moles of nitrogen monoxide formed from 13.44 decimeter cube? What is limiting? Limiting is the nitrogen monoxide, so 0.2 with 0.6, right? Oh my god, what am I doing? Okay, 1 second, guys, I'm so sorry. Guys, sorry again, I made a huge mistake. So it's 3NO2 and H2O. It's 0.25 and 0.2. This one is, sorry, this one is excess, this one is limiting. Okay, we know that. Okay, now that we know that, we can go to what they actually want. How many moles of nitrogen monoxide are formed from 13.44 decimeter cube of nitrogen dioxide? I did water before, that was my mistake. Okay, nitrogen dioxide at STP and 4.5 gram of water. Okay, so nitrogen dioxide, this is nitrogen dioxide and this is nitrogen monoxide. Okay, so we know when we balanced it, we got 3 to 2. No, oh, did we get 3 to 2? Or did we get yeah, we got wait, what? Oh my, okay, I'm confusing again, sorry. Actually crashing out. I'm so sorry, guys. Look, it's NO2 and NO, not HNO3. Okay, nitrogen monoxide is this one, and nitrogen dioxide is this one. I'm so sorry. uh, NO to NO2. We know NO2 is 2, no 3, sorry, yeah, 3, and NO is 1. Okay, that was the coefficient when we balanced it, remember? And we found out that NO2's moles was 0.6. Yeah, we divided by 3 because we wanted to find the ratio as excess and limiting, but then without that the mole was 0.6 for NO2. Okay, so 0.6. Now how many moles of nitrogen monoxide are formed? Just, yeah, just do that. You're going to get 0.2 moles. Yeah, that's all. Okay, guys, thank you very much. And I'm so sorry for all the stupid mistakes, but good luck in your exam. And if there was any mistakes, please tell me, okay? And yeah, if you need any help, please DM message me, okay? Ask me, don't hesitate. Thank you for watching.